Good afternoon. Good afternoon.
Good afternoon.
Good afternoon.
What was the last thing we dealt with in the previous class?
Sir, the force exerted by a chain
on the
that
platform,
is falling
and the
down.
platform is
Chain
also
problem.
accelerating.
Yes,
Sir, when it does not form a heap.
Yes, sir, chain problem.
Okay, we introduced variable mass.
Yes, sir.
Yes.
Did we deal with the derivation for rocket propulsion?
Yes, sir.
Yes.
sir.
Yes, sir.
Yes, sir. Last thing we did was chain problem, sir.
In where platform was also accelerating.
Okay. Sounds good. Now, one typical set of problems when it comes to a chain. Direction of thrust force is an issue. So when you want the direction of thrust force on one small element, disconnect the chain there and place a string of negligible mass. Direction of tension in that string is the direction of thrust force. I repeat, suppose I tell you there is a heap of chain here, and I am pulling this chain in the upward direction and lifting the chain. What am I doing? I am lifting the chain in the vertically upward direction. This is the chain like this. This is the chain like this. I am lifting the chain. Now I am interested to know what is the force I exert for the chain to move with uniform velocity. Force to be exerted for the chain to move with uniform velocity. Force to be exerted for the chain to move with uniform velocity. Firstly, did you understand the question?
Yes, sir.
Yes.
Sir, can you repeat it once again?
Yes, sir.
The force I should exert for the chain to move with uniform velocity. If this is x, what is the force I should exert for the chain to move with uniform velocity? Right? You may feel at the first place, the force I exert should be equal to weight of the chain. For it to move with uniform velocity, force is lambda x into g, weight of the chain. If I want the marker to move with uniform velocity, what is the force I should exert? Equal to the weight of the marker, right? For the marker to move with uniform velocity, what is the force I am exerting? Equal to the marker. Here there is a small change. The heap of the chain means the small element which just started moving was initially at rest. The small element which just started moving is initially at rest. It was at rest, suddenly it starts moving. So this small element is subjected to a change in momentum. This small element is subjected to a change in momentum. This small element is subjected to a change in momentum. Right? connect these both by a string of negligible mass. Direction of tension is the direction of the thrust force. Connect this element of the chain and this element of the chain by a string of negligible mass. बीच में आप कहां से string ले आओगे यार? String doesn't have mass, so I'm not changing the problem. String doesn't have mass, so I'm not changing the problem. You're connecting the string. You're connecting the string between this and this. You're connecting the string between this and this. Right? So this string doesn't have any mass. Then why did you connect the string? To know the direction of tension. That will be the direction of the thrust force. Are you trying to tell me that for this chain thrust force will be downwards, for the heap thrust force will be upwards? Yes. And why will there be a thrust force? A small element at rest suddenly started moving. Is there a change in momentum?
Yes, sir.
A small element at rest suddenly started moving. There is a change in momentum. So this plus thrust force, weight plus thrust force will be the net total force I should apply for the chain to move with uniform velocity. Lambda x into g plus lambda v square is the force I should exert for the chain to move with uniform velocity. For the chain to be lifted with uniform velocity. For the chain to be lifted with uniform velocity. Obviously, now there will be a reverse for this problem. We will keep the heap of the chain on the table. From underneath, it will start falling. Can I rub the board?
Yes, sir. Yes.
Yes.
This is a table with a hole on the top. What is this?
Table with a hole on top.
Right?
Yes, sir.
You have kept a heap of a chain on the top of the table, and from underneath you slightly pulled and released. Slightly pulled and released. Right? So the chain will start slipping. You want the velocity of the chain as a function of x. Find velocity of chain as a function of x. Find the velocity of the chain as a function of x. Now listen, there is one way of analyzing this concept. First thing that will strike to the human mind is loss in potential energy is gain in kinetic energy. As the chain is falling, and actually we have done such type of problems, right? If you people observe work energy theorem, did we do such type of problems?
Yes, sir.
Yes, sir.
Now, loss in potential energy should be gain in kinetic energy. What is the difference between these two problems? The difference is like this. Observe this. Here, every element of the chain is traveling with the same speed. Here, only this part of the chain is traveling. This heap which you consider will technically be like this.
Are you frozen?
Sir, you froze.
Sir, your screen is frozen.
Yes.
So now it's fine. Now it's
Now it's
perfect.
correct.
Now it's proper, sir.
Okay.
Sir,
Sir, it is still frozen.
Okay.
Sir, it's back.
Concentrate. Okay, listen. Now, see, this heap of a chain is at rest. The lower part of the chain is moving. There is a difference between the two situations. Here, every part of the chain is moving with the same velocity. Every part of the chain is moving with the same velocity. Here, every part of the chain is not moving with the same velocity. Why will thrust force come into the picture? This part of the chain was at rest and suddenly it started moving. So there is a sudden change in momentum. So on this, the thrust force will be downwards. On this, the thrust force will be upwards. Right? On this, the thrust force will be downwards. Here, there will be no thrust force. Every part of the chain is moving with the same velocity. Now recollect one more important point. If you people remember, there is comprehension 3 of work power energy in your booklet, where they gave you ground this way. Now when the chain is hitting
Yes,
the
sir.
ground, it is an inelastic collision. So you cannot conserve energy there. What did you do? You put dynamic equation and you solve. When the chain is striking the surface, you cannot conserve energy. It is inelastic collision. It strikes the ground and it comes to rest. You didn't conserve energy. You use the dynamic equation. If this ground did not exist, then I am fine with this. Loss in potential energy is equal to gain in kinetic energy, which we did. Here, when I had ground, the chain was striking the ground and coming to rest. The chain was striking the ground and coming to rest, right? If it is striking the ground and coming to rest, it is inelastic collision. I cannot conserve energy. Now have a look at it. Something at rest suddenly started moving. This is also inelastic collision. Something at rest suddenly started moving. I cannot conserve energy. There is a thrust force. I cannot conserve energy. There is a thrust force. So this element which was at rest suddenly started moving. This element which is at rest suddenly started moving. Right? So here I am forced. What all have you learned in mechanics till now? One is dynamic equation. One is conservation of energy, which is eliminated here. Why is it eliminated here? Example of an inelastic collision. Why is it inelastic collision? Element at rest suddenly started moving. Conservation of momentum is the third thing you have learned, which cannot be done because there is a normal force on the heap of the chain. There is an external force, gravity. External force, gravity is there, normal force is there. So momentum cannot be conserved. Energy cannot be conserved because it is example of an inelastic collision. The only other thing that you have learned in mechanics is dynamic equation. It looks absurd, right? Right from the time you join, you have learned three things till date. Dynamic equation, conservation of energy, and conservation of linear momentum. Didn't you learn much lesser than what you should have learned?
Seems so.
तो मैकेनिक्स में इसके अलावा और क्या होता है?
काफी है. Rotational dynamics is equally long as mechanics. Now, anyway, listen. So, out of the three things that you have learned in this problem, I cannot apply conservation of momentum because I have a normal force and gravity. I cannot conserve energy just as I did in this case because there is a thrust force acting in between. It is an inelastic collision का example. An element at thrust suddenly started moving. तो यहाँ क्यों conserve किया था यार तुमने? हाँ, यहाँ मैंने conservation of energy apply किया because there was no thrust force in between. Every element was moving with the same speed. It is not an inelastic collision example. So now back to work with this question. Other than dynamic equation, you do not have any other choice. So what is your dynamic equation? Lambda x into g minus thrust force is lambda x into dv by dt. Wait, minus thrust force. I am writing the dynamic equation for the hanging part of the chain. I am writing the dynamic equation for the hanging part of the chain. Lambda x into g minus thrust force is mass into acceleration. Lambda x into g minus lambda v square is lambda x into dv by dx into dx by dt. Did you understand what I did till here?
Yes, sir.
dv by dt I wrote as v dv by dx. Thrust force I put as lambda v square. You are aware of this. Lambda x into g is lambda v square. Lambda x v dv by dx. Lambda will go. X g v square plus x v dv by dx. Did you understand what I did till here?
Yes, sir.
Yes, sir.
Now the trickiest part of the simplification comes. I know it will not be easy, neither will this idea strike to you in one go. It will take time, but make an attempt. I need v as a function of x. I need v as a function of x. You do not have any other equation which comes to your result.
So do we write it as dx by dt?
dx by dt लिख लोगे तो फिर टाइम ले आ रहे हो ना यार. टाइम को मैंने यहाँ से एलिमिनेट किया है. what v as a function of x. फिर वापस dv by dt में चला जाओगे.
So can you give 2 minutes to think?
Yeah, take it down, make a proper attempt. Not an easy way of simplifying. It's a very tricky situation.
Sir, I still don't understand how is it an example of inelastic collision.
If the chain falls on the ground and doesn't bounce, is it inelastic?
Yes, sir.
Here it is the reverse. It is at rest, suddenly started.
Oh, okay, sir, got it.
Sir, one doubt. Can we solve these given the measures that we have?
Your statement is, can we solve these given the measures that we have?
Sir, I mean to say whatever we learned in calculus for physics, are we able to solve this using that?
Yes. Yes,
Okay, sir.
but it's a very tricky situation. You know everything required, but how will the idea strike at that minute? I cannot say. It will not. At the first instance, it will not.
Okay, sir.
Do we need to make any substitution here?
No. I need velocity as a function of x.
So,
Hmm.
can I say that how I did?
No, wait.
Okay, sir.
What is the answer you got?
Sir, I thought the approach. I haven't final calculation.
Do attempt.
I'm doing that. Sir, gx equals to 3v square.
No.
Okay, sir.
Sir, is it gx equal to v square?
V in terms of x style. Gx नहीं. V in terms of x.
V is equal to root gx?
Root gx is wrong.
So 3 root gx, root 3
नहीं.
gx.
नहीं.
Sir, we shouldn't have g term in it, right?
No,
Sir,
we
हम
should
v
have.
सर हम v के टर्म में क्वाड्रेटिक नहीं बना सकते.
Ifs buts नहीं. Tell me the answer. V in terms of x style
Sir, is V equal to root 2gx by 3?
is correct. Root is whole root or only root 2?
Whole root over 2gx by 3.
Is correct.
Sure, wait for 2 more minutes.
Sure.
So can you write the final answer on the board? Thank you, sir.
Now listen to this. Multiply all throughout by 2x. What did you do? You multiply all throughout by 2x. 2x square g, 2x v square, 2x square v dv by dx. This can be written as d by dx of x square v square. Open up and verify. U into v. First I differentiated x square, it is 2x. I kept v square as it is. Then I kept x square as it is and differentiated v square with respect to x. It will become 2v dv by dx. Change of differentiation of v square with respect to v is 2v into dv by dx. This is equal to 2x square into g. 2x square into g into dx is d of x square v square. 2g x cube by 3. What is integral dx? X integral d of x square v square is x square v square. Now, how will it strike to us that we'll have to multiply this with x, 2x? It's like this. When I see the right hand side, I have got dv by dx. I have two variables and only one equation. I should express one in terms of the other. So when I have got dv by dx, I'll have to think in these lines of expressing it as a perfect differential. Perfect differential means the right hand side should be d by dx of something. Now here I have got v square. So I have two options. I will try for x into v square, x square into v square. Because I have got v square. X into v I cannot try. Already got v square. 1 second, wait, there is some call coming. Are you able to hear me?
Yes, sir. Yes, sir.
So now, because I have got v square, I'll try both the options. X into v square, x square into v square. X into v square is not working out for me. Whatever I multiply, I cannot express this as d by dx of x into v square. So next option is x square into v square. What should I multiply to get that? We try all options, and hence you get this conclusion. How will this idea strike to us? Once second order differential equations are taught to you in maths, you will also develop these ideas. It's a question of time.
So, is it, sir, why we can't multiply dx in whole equation and then integrate it?
You want to multiply with dx on whole equation and integrate it.
Yes, sir.
Now, how will you integrate that? You
X.
multiply it with dx. X v dv.
Yes,
That
sir.
means you consider x to be a constant.
Understood, sir. Understood. Thank you, sir.
Sir,
Uh,
sir, I didn't understand the right hand part of the integration.
what is integral dx?
X.
Integral d of x square v square will be x square v square. Integral and d will get cancelled out.
Okay, got it. Thank you, sir.
Can I rub the board?
Wait, sir.
Wait, sir.
Yes, sir. Wait, sir.
Sir, you call this collision inelastic because kinetic energy is not conserved, right?
Yeah,
Okay, sir.
energy is not conserved. Potential plus kinetic. There is work done by impulsive force.
Yes, sir.
Noted, sir.
One typical problem where it is beyond your scope, basically picked up from 200 puzzling problems in physics. It will be difficult for you people to visualize, but please learn this. Have a look at it. This is a carpet. This is a carpet on the floor. Now he is telling you, you fold the carpet and start pulling it this way. What is the force I should exert for the carpet to move with uniform velocity? The lower part of the carpet is at rest on the floor. So which part of the carpet is moving? The upper part of the carpet is moving. He's asking, it was similar to the situation where I am pulling a chain in the upward direction, but with a small twist, something which we fail to observe when we visualize. Mathematically only we get. I repeat the question. What is the force I should exert on the carpet so that the carpet moves with uniform velocity? Right? What is the force I should exert on the carpet so that the carpet moves with uniform velocity? Did you understand the question?
Yes, sir.
Yes, sir.
Sir, the mass of the carpet is distributed over area, right?
all over, it is uniformly distributed. Consider lambda to be the mass per unit length. Now, if I consider this point to be fixed, this is the way of pulling the car. This is the way you are pulling the car. Are you able to visualize this?
Yes, sir.
Find the force exerted on the carpet to move the carpet with uniform speed. Find force exerted to move the carpet with uniform speed. Now, generally the mistake that students commit here is they say small element of the carpet is at rest which suddenly started moving with a velocity. Small element of the carpet is at rest which suddenly started moving with a velocity v. So frequently committed mistake by the students is they give the answer as lambda v square. It appears actually first place we cannot find fault with the student, but this is wrong. Right? Why is that wrong? Please observe this carefully. Watch out for it. I take this distance to be y, this distance to be x, so this distance will be x. Say something, yes or no?
So, sir, you are taking the part in the mass in the curved part is negligible.
The curved part is negligible.
Oh, then okay.
So this distance is x, this distance is y. So if x length is folded here, this distance is also x. So
Yes.
total length
Yes.
of the carpet is 2x plus y. Do you agree with that?
Yes, sir.
Yes, sir.
Now observe very carefully. dl by dt is equal to 2 dx by dt plus dy by dt. What have I done?
Differentiated.
Differentiated with respect to time.
Beauty is this will be 0. Why?
Uniform speed.
Inextensible.
Dx by dt will be dy by dt by 2. And in fact, dy by dt will be v. dy by dt will be minus v. Why? This end is fixed. This end is approaching. So the rate at which y is decreasing is v. This end is fixed. This end is approaching the fixed end. That means the rate at which y is decreasing should be the velocity. Recollect, in calculus you were taught this. This is x and y and L. You said L square is x square plus y square. If one end is fixed, dx by dt is the speed of this end. Yes or no?
Yes, sir.
Yes, sir.
If one end is fixed, the speed of this end is dx by dt. We learned this in calculus for physics. Now, this end is fixed. So this end is approaching with a velocity v. That means dy by dt will be minus v. Because y is decreasing. Now here dx by dt is minus dy by dt by dy by dt is minus v. Minus of minus is becoming plus v. So dx by dt is not v, is v by. Dx by dt is not v, it is v by. Dx by dt is not v, it is v by. अभी ध्यान से सुनिए. It will not be so that you can solve this problem on your own. You have to listen, please concentrate. For this part of the chain to move with uniform velocity, force plus thrust force should be equal to mass into acceleration. This is what you taught me in variable mass. Along with all the existing forces, add one more force called thrust force, equate it to mass into acceleration. But here you want it to move with uniform speed. So dv by dt will be 0. What is the force you need to exert? This is minus of Vr is V, d by dt of lambda x. How much is the mass which is moving? Lambda into x. How much is the mass that is moving? Lambda into x
Yes, sir.
should be equal to 0. F is equal to V lambda dx by dt. This answer would have been correct if dx by dt was V. Here dx by dt is V by 2 is the catch in it. Lambda V square by 2 is the answer. A typical problem which has to be taught. Whole of the game is because till now all the situations you were taking dx by dt to be V, and it was true. Dx by dt was V. So lambda V square was your answer. Here they have played in a very subtle way that dx by dt is not V, it is V by. I will convince you people in another way. Have a look at this. If I tell you there is a chain falling this way, it starts slipping at the right hand side. If this comes down by x, the lower end will come down by x by 2 and not x. If this chain is released from the right side and it falls by a distance of x, the lower end will come down by a distance of x by 2. Why? Because this x length is accommodated on the left and right, x by 2 and x by 2. That x by 2 here we kept it in the horizontal position to make it look a bit confusing.
So I have two doubts. One, I'm not able to understand why dy by dt is equal to V.
What should it be equal to then? This end point is approaching the fixed end with a speed V. That means that is the rate at which the length is decreasing.
Okay, so the rate of okay, so got it. And so in the on the right hand side, the second equation, how did you get a minus V? Is it you have taken the right side as negative?
Naturally, Vr dm by dt, no, it is not right side negative. Thrust force will come with minus Vr dm by dt, no, yeah.
Because you written plus on the above equation, that's it. Okay, sir.
Sum of all the forces is mass into acceleration. Now, when I disconnect this and place a string, see, this is the element. I am pulling this with a force. Thrust force will be in the opposite direction. I'm okay. Write a negative sign from here. I'm okay.
You got it. You got a 0. Therefore, you need to get a minus. Therefore, uniform velocity.
See, this negative is because F and Ft are not in the same direction. How do you know that? You will disconnect that and connect it with a string of negligible mass. That string में tension का direction will tell you the direction of the thrust force.
Yes, sir, got it. Basically, you need 0 acceleration. Therefore, you need to equate both the forces.
Natural.
So this question was basically constraints in disguise.
Right. In disguise is the right word. That's the key catch.
From where this question was?
200 puzzling problems in physics. Cambridge University Press.
Sir,
Hmm.
you have considered the length of the curved part to be negligible, right?
Yeah, naturally. This curved path is negligible. That's why comfortably you could place a string of negligible mass.
Okay.
If somebody can directly see this v by 2, I have no problem with that. Directly substitute dx by dt as v by 2. But here I have given you a very authentic way of proving that dy by dt or dx by dt is v by 2. dy by dt is minus v. Chandravas ready, your mic is on, please switch it off. Can I rub the board?
Yes, sir.
Is fluid dynamics taught to you people?
No, sir.
No, sir.
No, sir.
Sir, we just know about barometer and pressure, how it changes.
Now suppose you hold a hose pipe, the thrust force will be this way. Hose pipe, water of density rho is flowing out. If you ever hold a hose pipe where velocity is quite high, you cannot leave the pipe. Leave the pipe will bounce back. A firefighter, when he ejects water from the hose pipe at very high velocity, not one, not two, more than two well-built firefighters will hold the hose pipe in position. If not, it will bounce back. It is like firing a bullet and the gun recoils back. So when water is coming out of a hose pipe, area of cross section is A. What is the thrust force he need to exert? VR dm by dt. Thrust force exerted, thrust force on a hose pipe. This will be V. dm by dt will be d by dt of density into area of cross section into the length dx that water has traveled. Density into area of cross section into the length, I will get the volume, into density is dm. This will be rho a v square. Thrust force exerted by a streamlined flow of liquid.
Sir,
Huh?
sir, in that rho a dx we have written, before that d won't come, right?
Before that,
Like d by dt you have written d by dt of rho a dx, that d won't come.
I wrote it 2 times. Right. This is rho a dx. So dx by dt is velocity. So rho a v square.
Sir, what was dx again?
Dx is the length of the water column that you are taking in that short time interval dt. In time dt, the length that water column has traveled.
Okay, got it. Thank you.
Sir, here V is volume, right?
Velocity. Dx by dt volume thodi.
Okay, sorry.
Sir, are we considering the water to flow with a uniform velocity?
Naturally, if not at one instant, dx by dt is instantaneous velocity. If velocity is changing, thrust force to be exerted will keep changing. We don't
Okay, sir.
expect density of water column to change. Area of cross section we have taken uniform. Can I rub the board?
Yes, sir.
This completes variable mass. I have only one more typical set of problem which need to be done. In fact, I'll have to explain this and then give you the problem. But for a change, I'll give you the problem and I'll explain it. Have a look at it. Two small bodies, A and B, are kept on a smooth horizontal table. Smooth horizontal table. You are having the top view. Who is this? You are seeing from the top view, right? It is a smooth horizontal table. Fine. Now, you have given a velocity of u to this. This length is given as 3L, right? This distance, right? And then inextensible string of length. Length of the string is 5L. Length of string is 5L. Now, MA is equal to M, MB is 2M. MB is 2M, MA is equal to M. So it's on a horizontal table and you gave a perpendicular velocity to you. First question asked is find the velocity of A and B when string becomes taut. String becomes T-A-U-T, thought, is the first rule. Find the impulse in the tension in the string. Find impulse due to tension in the string when it becomes taut. There is a third bit for it. I'll discuss that once you are done with the first two bits. Body P is given a velocity of u. Firstly, listen. When will the string become taut?
When the length of the string is 5L.
When it will move 4L in horizontal direction.
Right.
Yes, sir.
This is 2m, this is m, its velocity was u. Have a look at this. Should we take this to be theta? This will be 90 minus
Yes, sir.
theta. So this will be theta. So this u cos theta will remain as it is. U sin theta will change. Just before the string becomes taut, its velocity will be u sin theta. Just after the string becomes taut, its velocity will be v. Both will be v along the length of the string. If you have taken this as theta, no big deal. This is 3, this is 5. So cos theta will be 3 by 5. Sin theta will be 4 by 5. This u is the velocity just before the string became taut. T delta t, and this will be T delta. U cos theta and u sin theta were the velocities just before the string became taut. Just after the string became taut, the velocity is v and v. So far, so good. Yes or no?
Yes, sir.
Now,
Yes,
taking both
sir.
as one system, I can conserve momentum in any direction. There is no external force. Taking both as one system, I can conserve linear momentum in any direction. There is no external force. I would prefer
Yeah,
along
it's
this
cat.
direction because I need these both velocities. Taking both as one system, there is no external force in any direction. I can conserve momentum in any direction, but I will be conserving momentum along this. Why? Because we need these both velocities. This velocity I know already. So no, initial momentum in that direction is 2m into u sin theta. Final momentum is 2m into v plus m into v. 2m into v plus m into v. M gets cancelled out. 2u sin theta is equal to 3v. V is equal to u sin theta by 3. You know the value of sin theta, hence you get the value of v. Sin theta is 4 by 5. 8u by 15. 8u by 15. And this will be 3u by 5. Resultant velocity of these both is the velocity of 12, and this will be 8u by 15. Velocity of A will be 8u by 15. Velocity of B will not be only 8u by 15, it will be the resultant of both. Root over of this square plus this square. 64u by 225 plus 9u by 25. Add both and take the square root. Velocity of B will be resultant of these both.
So u into under root 145 by 15.
जो भी है.
Yes, sir, that's correct.
Oh.
Second bit, what was the impulse? T delta T, which was equal to mb minus 0. M into 8u by 15 minus 0 is the impulse T delta T. Is the impulse T delta T.
Sir, is this system kept on a horizontal table?
Yeah.
Okay.
That was the first line we said about this question.
Sorry.
So u cos theta is constant because it is in the tangential direction, right?
Perpendicular to the tangent.
Okay, sir.
थोड़ा ध्यान से सुनिए. Listen to me carefully. There is a third bit for it. I will give you the pros and cons and I'll give you time to solve as homework. I mean, no hurry first. Listen. The third bit is they're asking you the value of the tension T. They're asking you the value of tension T once the string has become taut. Can somebody give me an idea as to what you will do?
So T equal to MA and A we write as dV by dt.
Sir, F is dP by dt.
Sir, will it go in circular motion?
डेल्टा टी आप लोग सोच समझ के बोलिए, हवा में तीर मत मारो. T delta T is known to. Delta T is not known to. So how will you calculate T is the question. Eventually, after the string became taut, what is the value of T?
We can use circular motion.
Yes, it's a circular motion because both will have relative velocity
Idea
in this.
is good. Idea is good. Tension provides the required centripetal force 2m into this velocity square by radius. थोड़ा ध्यान से सुनिए. All of you listen. I put you people in soup and I leave you. Right? Now tension provides the required centripetal force. I will not take this velocity. I take this velocity because that is perpendicular. mv square by r, v should be perpendicular to the force providing centripetal force. Till there I am okay, but I don't know the radius. This is not fixed here. I don't know the radius. Idea is good. Tension provides the centripetal force. You will have to convert it to the center of mass frame, find out the velocity of this with respect to center of mass, then the radius will be half the length of the string. Did you people understand what I said? Eventually, you
No,
have to
sir.
find out the T. P will be mv square by r. V will be what? The perpendicular velocity. But I don't know the radius of the circular track. This is not fixed about that point. So think of your alternatives. Make a note of this statement. Third question. First of all, write the question.
So can you write it on the top?
Write the question बोल रहा हूँ. Can we write it in the top? आप कहाँ लिखोगे मुझे क्या पता. तेरा
Sir नहीं, आप सर आपको बोल रहा हूँ क्वेश्चन ऊपर लिख सकते हैं क्या?
अरे नहीं डिक्टेट करूंगा because I need whole of this. ऊपर it is glaring. Third question. Find the tension in the string eventually. Find the tension in the string eventually. Find the tension in the string eventually. Now solution में report. Tension provides the required centripetal force. Tension provides the required centripetal force. Tension provides the required centripetal force. In the bracket, hint, I don't know the radius. In the bracket, hint, I do not know the radius. I do not know the radius. Go figure out the solution, it is your head.
Sir, is it 5L by 3 radius? The center of mass will move with uniform velocity in the like.
Don't confuse the others. That's not the radius, right?
Sir, can you please repeat the question once?
Question is find the tension in the string eventually. Solution is tension provides the required centripetal force. So I should find out velocity perpendicular to the string, which I am sure I can find out, but I don't know the radius. So please figure out how you will go about with that problem. Spend time with that problem today evening. Do not jump to conclusions. Some people have already spilled the beans on it. They have spoken about the hint. Use that information. Solve. Your final answer, I tell you, is 6 mu square by 125 L. 6 mu square by 125 L.
So lecture is over.
Center of mass, conservation of momentum chapter is over. Homework, HCV, booklet complete. When is our next doubt lecture?
Friday.
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 Now, did we discuss HCV's doubts?
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Booklet discussion, did we start or did we not start?
First,
exercise
For
130
Yes,
sums were
1
done,
to question 30.
but 28 was left.
Okay, from 28, we'll continue in the doubt lecture. Please finish off your homework at the earliest. People who have got backlogs, did you people see the one that Anshul sir has made?
He said he will be like, he's testing it. He said he will provide us after some time.
Yeah, I have actually seen that it's good enough. People have got backlogs, try to use that. It's like making your job much easier than what you will do while searching. Whatever backlog you click on it, you will actually keep going into what you need.
Sir, a general doubt. Tentatively, by when will our backlogs get cleared if we use it regularly?
That purely depends on your ability of how much time can you give. If you don't
Okay, sir.
sleep for 2 to 3 nights continuously, backlog in one subject will be over.
Okay, fine, sir.
What's the
See you
app called?
people in the next class.
Sir, in next out lecture, how many exercises like we have to complete?
Till exercise 3 to guarantee khatam kar dunga main. Because
Sir, in the before
homework was given in the previous batch, previous class itself.
sir, in the next class in the starting, can you solve this question? The last part.
Obviously, मतलब आपको attempt भी नहीं करना है.
Sir, no, I'm going to attempt it. I just want to verify my
आप
solution.
अभी से बुक क्यों कर रहे हो? कोशिश तो करो, हो जाएगा शायद.
So
Okay,
in
sir.
next class we'll start with rotational dynamics.
Yes. With respect to A, you're telling me somebody is saying that they know the radius. A is not fixed. So if you want to find it out, do find out with respect to some point. Find out the velocity. Try that as well. If you take A, you will have to put pseudo force on it. A is an accelerating point. So see you people in the next class. Good day and thank you.